Assalamu alaikum, dear students. Now, today we are studying another topic, that is 9.2 wavefront. So, first we are going to define the wavefront as uh, the locus points, the locus points which are same in phase is called the wavefront. Okay, the locus points which are same in phase, that is called the wavefront. There are two types of wavefront. One is called the circular or the spherical wavefront. Okay, how we can define it? Uh, the wavefront which is formed near to the primary source, that is called which is formed near to the primary source. Primary source means the original source is called circular wavefront, or that is called the spherical wavefront. Okay. Uh, Another type is plane wavefront. So plane wavefront is defined as the wavefront formed far away from the primary source is called the plane wavefront. The wavefront which is far away from the source, that is called primary plane wavefront. Okay. Now remember, wavefront explain diffraction, so it is following inverse square law. Inverse square law says that whenever there is increase in distance, the intensity of the light will decrease. So intensity and the distance both are inversely proportional to one another. Okay. Now let us consider uh, we have a water pool. When we throw a stone in the water pool, so there is a disturbance produced in the water. If we throw the stone here in the water, so it will produce circular waves in all the direction. So circular waves will produced in all the direction. So it means that the disturbance will be spread out in the water. So this disturbance will be flow in the form of crust and trough. So look at here. So this disturbance will be flow in the form of crust and trough. So suppose the wave is flowing towards right. So this is crust, trough, and so on. 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 Okay. This is the crust. Here the potential energy is maximum. This is also crust. Here the potential energy is maximum. There is a crust. There is a crust. Okay. At this point and at this point and this point, these all 4 points have the same potential energy, same kinetic energy, same displacement, same velocity. So it means that these points are same state of motion. So it means that these points have the same phase. These points have the same phase. So whenever the points having same phase, and these are locus points, so these are called the wavefront. So if you combine all these points, so look at here, the position of these points is called wavefront. So for the wavefront, when the locus points having same in phase, these points are called the locus points. These are called the wavefront. Okay. Now, let us consider a light. This is a light source. This is a primary light source. It produces the waves. Whenever it produces the waves, suppose it produces 4 waves. So here there is a crust, there is a crust, there is a crust, and there is a crust. So all these points having same in phase, because at the crust position, the crust is an extreme point, and at the extreme point the potential energy is maximum, acceleration is maximum, restoring force is maximum, velocity is 0, kinetic energy is 0. So it means that these 4 points are same in phase. So if these are same in phase, so combining these points, so if you combine these points, so it will form a wavefront. So this position of the all 4 points is called the wavefront. Okay. So if you combine all these points, so this position is also called a wavefront. And remember, the distance between the two consecutive wavefront, that is called lambda. Lambda is the distance between the two consecutive wavefront. Okay. So spherical waves travel outward from the source, indicates the direction of propagation of wavefront. The arrows, as you notice here, the arrows which is moving away indicates the direction of wavefront, are called the rays. Okay, so these are the rays. The rays are always perpendicular to wavefront. Remember, these are rays which is always perpendicular to the wavefront. We can specify the motion of a wave either by using rays or driving the wave itself. Okay. So we can represent these waves in the form of straight line or in the form of waves. We can represent it. That is our choice. Okay. And remember, the straight portion in the lines, that is called the wavefront. Okay. This is all about the wavefront. If you have any query, then you can ask in comment section. Okay. Take care. Allah Hafiz.